Let's go ahead and introduce the concept of area here. And you've probably seen area before, but I'm going to try to explain it in a way that'll hopefully kind of lend itself to what we're going to learn later as well. So up until now, we've been talking about length. We also talked about angles, but we're talking about, kind of a measurement here in one dimension. So length is a one-dimensional measure. And what that means is, if you notice here, there's one direction we can go. Now we can go to the left or we can go to the right, but we have to remain along this line. So that's what I mean by one-dimensional, okay? And we can find the length of this particular figure. So let's make it a line segment. And we can count off these units. 1 unit, 2, 3. Okay. And so we have these different units, and I can literally just count them. But we're counting off one-dimensional pieces. So a length. This is 1 unit, so on and so forth. And we can add all of those up and find that this particular figure is 10 units long. Now, those units could be inches, they could be centimeters, they could be really anything, but the important thing is they're to the first power. They are a one-dimensional unit, a length. What we can then do, though, is we can up the ante, or just change it up and go to area. And you might be able to guess, if length is one dimension, now we're going to add a second dimension. So instead of just being able to go to the left and to the right, I'm going to be able to go up and down. Okay, and this is where we start talking about area. So instead of just counting these lengths, what we're going to do is we're going to count how many squares there are. And now we already know that this piece here is 10 units long. And then we just added a 1 unit kind of height in the other direction. So 2 directions. And so we have 10 units in 1 unit. Well, that means that we're going to have 10 square units. And that's literally because there's 10 squares there. And those, again, could be inches squared or centimeters squared or whatever. And we can continue doing this. Okay, and let's assume these are all the same size. I know my drawing skills leave a little bit to be desired at times. But what we're going to find is that if this first piece here had 10 units, and now we have a total of 1, 2, 3, 4, 5 of them, well, that means each one of these pieces is going to have 10 units. And so the area, the new area of this entire thing here is going to be 10 units plus 10 units plus 10 units plus 10 units plus 10 units. Well, hopefully you know a quicker way of doing that. If I have 5 groups of the same exact thing, we have a shortcut for that, and that is multiplication, which gives us a total of 50 units squared. And I'm sorry, these were all square units. So in this previous example, we started with just a segment and a one-dimensional length, and we kind of expanded it out. Well, what I'm trying to get at is we can actually take that concept and work backwards as well. So let's say that I have a 2-dimensional figure. I can break that up into its one-dimensional pieces and just kind of slice it up and make little bite-sized parts. And in doing that, we start to learn that we really don't need to memorize nearly as much stuff. So let's say that this was 4 units across that way and 3 units tall. Well, that's telling me that this is really 3 pieces here, and this is really 4 pieces here. Excuse my drawing. And again, I could count this multiple ways. I could just say, oh, I've got 4 square units, and then another 4 square units, and then another 4 square units, and add all of those up, and I get 12 square units, which of course we also see that we can just multiply the base and the height, and we get the same thing. Area is equal to 4 units times 3 units, but that's where that formula comes from. Okay, so all of this stuff is just kind of breaking things down into its smaller components. And we don't have to always break it down into individual squares either. Sometimes it's just going to be easier to say, hey, you know what? I've got this shape here. we know that these are right angles. Can be done in 1 sec. That's okay. We know those are right angles. And this is actually a trapezoid. Now, I haven't told you how to find the area of a trapezoid, but in reality, it actually doesn't matter too much, because what we can do is just cut up this figure into two pieces. Now, these pieces should look a lot more familiar. And I'm using some concepts we haven't gone over yet, but that's okay. I feel confident you can follow this. Now we have a rectangle and a triangle. And while you may not know the area formulas for those quite yet, you will soon enough. And, you know, instead of having to memorize the trapezoid formula, which you might want to do, or just look it up, you can just break this into a triangle and a rectangle. And it gives us a lot more flexibility in our thinking. Because, for example, if I knew that this was 3 units and this whole piece here was, let's say, 7 units, and that this piece down here was 10 units, obviously this whole thing's not to scale, well, I know that if this whole piece is 7 units and I cut off this piece right here, which I know is 3 units, well, 3 plus this piece has to equal 7, so this piece right here, it has to be 4 units. And 10 units here, a rectangle has opposite sides that are congruent. And so now if I want to find the area of the trapezoid, I know that it's just equal to the area of the rectangle plus the area of the triangle. And those formulas, like I said, are a little more common. The area of this rectangle we kind of just went over. You just take the base times the height. And the area of a triangle is actually very much related to a rectangle. It's actually half of a rectangle. So what we're going to do is we're just going to take the base times the height and cut that in half, or multiply it by 1/2. And so the area of the triangle is just 1/2 times the base, 10 units, times the height, 4 units. And we can go through and do all that arithmetic. And we find without ever knowing the formula for a trapezoid, and we find without ever even knowing the formula for a trapezoid that the area of this particular one is 50 units squared. And, you know, again, I breezed over some different concepts in some of these formulas, but the thing I really wanted you to get out of it is if you see an unfamiliar shape, just see if you can break it into multiple familiar shapes. And again, this is another theme that I've talked about and will continue to talk about, is if we have a complicated problem, our goal should be to break that one complicated problem into multiple simple problems that are easier to solve, and then combine them together to solve that bigger issue, problem, thing.